All right, now we're going to talk a little bit more about the quotient rule that we dealt with yesterday. We're dealing with higher order derivatives. We're going to start with finding the derivative of tan x. If you remember, it was bot to top minus top to bot over bot bot. If we don't really know what to do with the tan x. So I'm going to rewrite it using what we remember from trig. If you remember your quotient rule from quotient expression for tangent is sine x over cosine x. So I'm actually asking you to take the derivative of sine x over cosine x. Well, that's going to be the bot to top business. That's going to be your quotient rule. So that's going to be cosine x, the bottom, times the derivative of the top, which the derivative of sine x is cosine x, minus the top times the derivative of the bottom, which is negative sine x, over the bottom squared. And I'm going to do a quick side note up here. Cosine squared x does not equal cosine x squared. Cosine squared x does equal cosine x quantity squared. It's just a faster, more efficient way of writing that. All right, so this is cosine squared x plus sine squared x over cosine squared x. Well, that's 1 over cosine squared x. And yes, these are your trig identities coming back to haunt you from pre-cal. And 1 over cosine squared x, when we taught you simplification in pre-cal, you learned that that is equivalent to secant squared x because your rule was get rid of fractions if at all possible. So that's why this is true. And we're just saying it's just easier to memorize. You can go through this process every time. It's really not that horrible, but memorizing it is a whole lot more straightforward. So we're going to do it one more time. Okay, I'm going to rewrite this. It's the derivative of cosine x over sine x. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, this one ended up being with both terms negative, negative sine squared x minus cosine squared x over sine squared x. So that ends up being negative 1 over sine squared x, which is negative cosecant squared x. Again, it's easier to memorize. And we're going to remember this phrase. There's a trick. All trig functions that start with a c, the derivative is going to be negative. All right, we're going to continue on with these higher order derivatives. This is the derivative of 1 over cosine x. So that's cosine bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is negative sine x, over the bottom squared. That is positive sine x over cosine squared x. Now we're going to do a weird thing with simplifying. This is sine x over cosine x, which simplifies. We're going to combine those two, and then that's 1 over cosine x. So that ends up being tangent x secant x. Okay, so we're starting to see a pattern. If we wanted to just anticipate this, which I'm hoping you can, this is a derivative of a trig function that starts with a c, so we know it's going to be negative. Well, cosecant is if we look at the pattern from the previous page, secant's always been friends with tangent. If you remember in your trig, tan squared x plus 1 is equal to secant squared x. So instead of, since this is secant and this is secant, we know those match up. So we're going to think that cosecant is going to be friends with cotan. Okay, and the last thing we touched on yesterday, we're touching on again today, normal lines are perpendicular. It's not that people have trouble understanding this, it's that they don't read the question carefully. Okay, if I want a tangent line, you just take the slope as given. If I want a normal line, that means I need my perpendicular slope, so that's going to be -1/2. So if I want the tangent line, given the information, that's going to be y minus 5, because this is the coordinate point 3, 5. That's y minus 5 is equal to 2 times x minus 3. Calculus is wonderful. We get to leave the question, we get to leave our answer in this form. My normal line is going to be y minus 5 equals -1/2 x minus 3. And that's it for today.